All right, so this video, I'll be recording the second part of Lab 6. So we are going to continue in Section 3 on calculating probabilities. And what we have here is a definition. This is a review of the two conditions that constitute a probability density function. So firstly, oh, my computer's pressing funny. So firstly, we have the density function at any value is greater than or equal to 0 for all x. And the total area under the function is 1. Now it's possible for the density to be greater than 0, or greater than 1, I should say, for a continuous distribution, but it still restricts that the whole area is 1. So we'll see why that is here with some examples. So here is a function I've made to shade in an area of the normal distribution. So what you see here, you don't have to mess with. It's a function itself that I'm building that will take in the mean, mu, the standard deviation, sigma, and the x and the y bounds that I want to shade in. So that way you can see this normal distribution shaded in. And by default, I shaded in gray. So what's the area of this? This whole area, according to condition 2, you can answer. That's your first question here. So the main reason we want to consider these distributions is so we can calculate probabilities of different events occurring. So the first kind of probability we're going to calculate is called the lower tail probability. It's the area below a certain value. And so this is why the pictures are so useful. Here we have a graph that's going to be the distribution of the ACT scores 30 or less. So we got the mean here is 21. That's the center of the distribution. Sigma just determines how spread apart it is. And then I want to shade from everything from -10, so as far left as we can distinguish on the graph, up to 30. So we want to find out the probability of getting less than a 30, so that corresponds to the shaded region. And just think, is that could be more or less than a half based off what we've seen here? Since it's more than half the area, we should see we're going to get a pretty big number. And so here is how we're going to calculate these probabilities. We're going to use this special function pnorm. And what pnorm takes, firstly, is the value we want to have the lower tail probability for. And then we always want to specify the mean and the standard deviation. And if we run this, it gives me a probability, 93%. So this says this area here is 0.93, and it tells us there's a 93% chance of getting less than a 30 on this score. So here are some examples we can practice using pnorm to find the following. So if I want to do the same thing again, I'm just going to save me some time and copy paste it. I want to find the probability of getting less than a 25 here. So less than a 25 on this same test. I say 25 corresponds to this value here. And same mean and standard deviation, since it's distributed normal, 21 means 6 standard deviation. So it's a little bit less, 74%. And if we're going to change it to a different test, the skill that we're using really is translating what different parts of this problem go into our function. So if this is the mean, I should put that here. The second number is always the standard deviation. I put that here. Then we're going to find out what's the chance of getting a 1600 or lower. So pretty slick, pretty easy. Lower tail probabilities are quite, they're the basic probability to find. It gets more complicated when we find the probability between two values. So here's what we want to plot. What's the chance of getting between a 25 and a 30? So if I want to know that, here's the shaded area. You can see that's kind of a smaller region. And the real way to do it, the way to solve this problem is with two lower tail probabilities. So let's see. if we take the lower tail from 30, we know how to find that. And we also know how to find the lower tail from 25. And so you see that blue area? If we subtract the red area from the blue area, you'll find we get the purple area, the area in between. So that's a bounded probability. And so to find it, to find that chance of getting between a 25 and a 30, we would take the lower tail of the 25 minus the lower tail of the 30. That's how we're going to do these two-sided probabilities. And so we're going to look at a lot of examples like this in class. So hopefully you'll have seen this already by the time you're watching this video. But by way of review, you might want to pause and think about this, how those two areas subtracted gives you the area in between. It's a key geometric aspect of solving these. And I'm just going to go through one of these examples, maybe two, and then let you do the rest. So to do this one, we're going to have to change the mean because we're looking at the SAT now. Different mean and standard deviation. Get those right. And we're wanting to know the probability of getting between 1100 and 1400. So 1400 goes on the right because that's going to be the bigger lower tail. And 1100 goes on the left. If you flip them, you'll still get an answer, but it will be a negative, and we usually don't want probabilities to be negative. We can't have negative probabilities. So let's see. I'll do this one now too. This one's tricky because we're given height. Mean height is 70 inches. Standard deviation of height's 3.3. So if we want to find out the probability between being 5 foot 5 inches and 6 foot, we got these answers in feet when really our distribution is measured in inches. So we got to translate 6 foot into inches, which that's going to be 6 times 12 inches aren't a foot. So that's 6 foot in inches. To put 5 foot into inches, 5 foot 5 inches, we would say 5 times 12 plus 5. So this is my comment that says 5 foot 5 inches. So now to find the difference between these upper and lower probabilities, we would say, I'll just say the upper since I've already generated that value. Mean 70, standard deviation 3.3. And I know I'm going fast. You'll get fast at doing these too. There we go. So you can run that and see if you get an answer that makes sense. You'll get a probability that should correspond to what you would think the average height of people is. 5.5 and 6 for men. And it looks like I said PR norm. It said I can't find that function. Typo. There we go. Okay. Lastly, we got upper tail probabilities. So this is finding a value that's greater than something. So here's the picture. What if I want to find this shaded area, 30 and above? We're going to use the same geometric reasoning. If we consider the fact that the whole area is 1, we could just take 1 minus the lower tail. And that's what I have explained here. So to find this shaded region, we would find the area of the lower tail, which is P norm 30, and subtract 1 from it. So again, you'll want to consider this problem for multiple angles and get comfortable because it's easy to forget what the lower tail and upper are. But remember, R always will find the lower tail. So to find the upper, we got to do some extra work. So let's find the upper tail. What's the percent of getting above a 1600? Remember, that's like a I think that's a perfect score on the SAT. So we'd say 1 minus P norm. Since it's upper tail, 1 minus. And we do the exact same thing. 1600. Oh, and if you want to be like kind of lazy, you can just type these in the right order. Mean second, standard deviation third. And that's the same thing. And lastly, it's quantiles. You can pause and do the rest of the work before we continue with quantiles. Quantiles is the reverse of what we did. Given that you know a probability, what value corresponds to the score that is above that percentage or that proportion of your sample? So you're taking the GRE, and again, this is the graduate record exam. If you're going to grad school, you're probably going to take this. This particular test has a mean 151 and standard deviation 7. So if you're going to school that says they only take the top 80% of students, well, then what score do I need to take? This is the probability. I have to have a probability that's better than 0.8. What score do I need to take? So here, we're going to use a different function called QNorm. Q corresponds to quantile. And QNorm takes in a probability. You notice if I type this in, it says P. So I could say P is my probability, 0.8. And then everything else is the same. Mean, put in 151, standard deviation is 7 for this test. And this will tell me the score I need to make to get better than 80% of students. So reverse problem, but the same geometric reasoning. So it helps to draw a picture. You're going to say, hey, I'm going to draw this picture. 151 is in the median. I'll do this here. If you want to get the intuition for this, here's your picture. 151 is the mean. I want to know what area corresponds to 0.80, 80% of students. What score? To answer that question, we'll do QNorm. QNorm takes in your P and gives you output of a quantile, Q. So remember, the median, that's the 50th percent quantile, and the first quartile is the 25% quantile, if that helps connect what we were doing with box plots earlier. Okay, I think that's it. I think the rest of this lab is going to be on you. Good luck, and please come with questions.